the concept of one-sided limits is also essential in evaluating the limits of radicals. So let's recall that, say we have n is even, and limit of f of x as x approaches a is greater than 0, then the limit of the nth root of f of x as x approaches a is actually equal to the nth root of the limit of f of x as x approaches a. However, if n is even and the limit of f of x is less than 0, ibig sabihin nito negative, okay? Negative yung nasa loob. So the limit of the nth root of f of x as x approaches a is actually DNE or does not exist. Okay? So kapag negative yung limit ng f of x natin, DNE. Pag n is even. Pero kapag positive siya, we can get actually a limit. That is the nth root of the limit of f of x. Now, question is, meron tayong greater than 0 na limit at meron tayong less than 0 na limit. How about if the limit of f of x as x approaches a is equal to 0? How will we find the limit? So, dito ngayon papasok ang one-sided limit. Now, let's consider this function, f of x equals x minus 4. Observe that as x approaches 4 from the right, means x approaches 4 from the right, yung f of x natin passes through the positive values as it approaches 0. So we denote that as f of x approaches positive values as it approaches 0. On the other hand, as x approaches 4 from the left, saan naman dumadaan si f of x natin? F of x approaches 0 passing through the negative values. Okay? So, nung kinuha natin yung 4, in-approach natin yung 4 natin from the right, nakita natin dadaan pala siya sa positive values bago makarating sa 0. At kapag yung from the left naman of 4, dadaan naman siya sa negative values bago niya ma-approach si 0. This leads now to the following theorems. Theorem 1. So let n be an even positive integer. If x approaches a and f of x approaches 0 through positive values, so this is our notation, then we say that the limit of the nth root of f of x as x approaches a is equal to 0. And theorem 2 states that, so we let n be an even positive integer. If x approaches a and f of x approaches 0 through the negative values, then the limit of the nth root of f of x as x approaches a does not exist. So let's consider this example, the limit of the square root of 3x squared minus 5x plus 2 as x approaches 1. If we substitute 1 here, observe that the square root of 3 times 1 squared minus 5 times 1 plus 2 is actually equal to the square root of 0. So in this case, our f of x is equal to 0, or the limit of f of x is equal to 0. So hindi natin pwedeng gamitin yung So in this case, the limit of our f of x is actually equal to 0. So the limit of f of x as x approaches 1 is actually equal to 0. So we should consider the one-sided limits as x approaches 1 from the right and as x approaches 1 from the left. So we now have a, the limit of the square root of 3x squared minus 5x plus 2 as x approaches 1 from the left. So kung titignan natin ito, we can actually factor this out. This becomes the limit of the square root of 3x minus 2 and x minus 1 as x approaches 1 from the left. Observe that by direct substitution, okay, ipasok lang natin yung 0 dito. So we have 3 times 0 minus 2. So that is the square root of 1 times, eto naman, x minus 1 is equal to 0. But, if we observe, saan ba dadaan si x minus 1 natin? That is passing through the negative values of x. Tama? So, tignan natin. Negative values. Tignan nga natin, ano ba yung mga nasa negative ng 1? We have 0. 0 minus 1 is negative 1. Which is negative, right? Ano pa? Negative 1 minus 1 is equal to negative 2. Negative 2 minus 1 is equal to negative 3. So, bago siya makarating ng 0, dadaan siya sa negative values. Kaya, 0, negative. And 0 negative times 1 is actually square root of 0, negative. At anong sabi kapag 0 negative? The answer is DNE. So for the second part, we wish to evaluate the limit of the function as x approaches 1 from the right. So we can actually factor that into 3x minus 2, x minus 1 as x approaches 1 from the right. By direct substitution, that is 1 times what 0? Left or right? Tignan natin. So, from the right of 1, we have 2. 2 minus 1 is equal to 1. 3 minus 1 is equal to 2. 4 minus 1 is equal to 3. So, dumadaan siya sa positive values bago siya makarating ng 0. So, we see that this is 0, positive. Okay? And 1 times 0 positive is just equal to 0 positive. And by our theorem, we say that this is now equal to 0. From the result, we have shown that the limit of the function as x approaches 1 from the right is from the previous result, we have shown that the limit of the function as x approaches 1 from the left does not exist, and the limit of the function as x approaches 1 from the right is equal to 0. Since they are not equal, then we say that the limit of the square root of 3x squared minus 5x plus 2 as x approaches 1 does not exist. So we consider this example, f of x is equal to x squared minus x minus 6 whenever x is less than 3, and the fourth root of x minus 3 whenever x is greater than or equal to 3. And we wish to find the limit of f of x as x approaches 3. So to find this, we have to evaluate the one-sided limits. So the limit of f of x as x approaches 3 from the left. So eto ang gagamitin natin. So we have the limit of x squared minus x minus 6 as x approaches 3 from the left. Since this is a polynomial, so pwede lang nating ipasok yung 3. So we have 3 squared is 9 minus 3 minus 6, which is equal to 0. For letter B, we have the limit of f of x as x approaches 3 from the right. So this is now equal to the limit of, etong gagamitin natin kasi from the right, fourth root of x minus 3 as x approaches 3 from the right. Observe that we have a radical here, the fourth root of x minus 3. So by using our previous theorem, by direct substitution, that is the fourth root of what? 0. So check natin. From the right, so we have 4 minus 3, 1, 5 minus 3, 2, 6 minus 3, 3. So if you observe, bago siya makarating ng 0, it will pass through the positive values. So we have 0, positive. And by our previous theorem, this is equal to 0. Therefore, the limit from the left is 0 and the limit from the right is also 0. Therefore, the limit of f of x as x approaches 3 now is equal to 0. In summary, if we are looking for the limit of the nth root of f of x as x approaches a and the limit of f of x as x approaches a is equal to 0, we have to look for the values that f of x will pass through. Okay, if f of x passes through the positive values, then the limit of the nth root of f of x as x approaches a is equal to 0. But if f of x approaches 0, passing through the negative values, then we say that the limit of the nth root of f of x as x approaches a does not exist.